Various theories about the nature of light have been proposed from time to time. Some of the main theories are corpuscular theory, wave theory and quantum theory. Corpuscular theory. In 1637, Descartes proposed the theory and was further developed by Isaac Newton. According to this theory, light consists of tiny particles called corpuscles. This theory could explain reflection, refraction, scattering, total internal reflection and dispersion. Second one is wave theory. In 1678, Christian Huygens put forward wave theory of light. According to this theory, light travels in the form of waves. This theory could explain reflection, refraction, interference, diffraction and polarization. Max Planck put forward quantum theory. According to this theory, light travels in the form of small packets of energy called quanta. Light has dual nature, both particle nature and wave nature. This theory could explain all phenomena of light. We can start with Huygens principle. First, we can discuss what are wavefronts and rays. Suppose a stone is thrown on a surface of still water. Okay, suppose stone is thrown on the surface of still water. So, from the point of disturbance, what are produced around? Waves are produced. Okay. So, from the point of disturbance, waves are produced in different directions, like this, waves are produced. So, similarly, according to Hygiene, from the light source, light is also traveling in the form of waves. Okay, so here this is the light source. This is the light source. From the light source, waves are traveling. From the light source, here light is traveling in the form of waves like this. Okay, from the light source, yes, this is the light source. Light waves are traveling in different directions. I have drawn 4 light waves. Okay, we can consider infinite number of light waves traveling, propagating from the light source. Here, what is this point called? If you consider a wave, if you consider a wave, here A, B, C, D. Here A and B are called crust and C and D are called trough. Crust and trough, that you know. So, crust regions are A and B are crust and troughs are C and D. Okay, so here in these waves, number of crust and troughs are there. For example, if you consider the crust, the first crust of all the waves can be joined together and it forms a circular region, and this circular region is called a wavefront. Okay, so wavefront means wavefront is the region of constant phase. So here if you consider these infinite number of waves at the point, okay, at the point if you join the crust of all the way, it gives a wavefront. If you cross the trough of all the waves, it gives another wavefront. It gives, if you join the crust of all the second wave, it gives another wavefront. So like this, from the light source, light is traveling in the form of wavefront. Okay, so according to Huygens principle, light from the light source, light is traveling in the form of waves. Okay, and if you join the crust of all the points, all the waves, it gives a wavefront. If you join the trough of all the waves, it gives another wavefront. Again, if you join the crust of the second wave, it gives a wavefront. So, according to Hygiene, light travels from the light source in the form of wavefronts. Hence, definition of a wavefront is defined as continuous locus of all the particles of the medium which are vibrating in same phase at any instant. Okay, so it is a continuous locus of all the particles of the medium which are vibrating in constant phase. Or wavefront is also defined as it is a region of constant phase. It is a surface of constant phase. So here if you consider this one, this is the wavefront, and here all the particles are vibrating at constant phase. So it is considered as a region of constant phase. Okay, from this is a light source, S is the light source, this black circular region represents a wavefront. So this represents a wavefront. Okay, it is a region of constant phase. And these are perpendicular to the wavefront, and the lines which are perpendicular to the wavefront are called rays. So these are all rays. So rays are always perpendicular to wavefront. That's a very important point. Okay, so what is a wavefront? It is a region of constant phase and rays are mutually perpendicular to the wavefront. Okay, similar to electric field and equipotential surface. So, electric field and equipotential surface are perpendicular. You have studied this in the second chapter. Similarly, rays and wavefront are mutually perpendicular to each other. So, we can say a ray is always perpendicular to wavefront. Then the speed with which wavefront is moving outward from the light source is called the speed of the wave. The speed with which wavefront moves outward. So, wavefront is moving outward from the light source, wavefronts are propagating outward. Okay, so the speed with which wavefront moves outward from the light source is called the speed of the wave. So, what is a wavefront? It is a region of constant phase. Wavefront and rays are mutually perpendicular to each other, and the speed with which wavefront propagates outward or moves outward from the light source is called the speed of the wave. Now, we can discuss different types of wavefronts. There are mainly three types of wavefronts: spherical wavefront, plane wavefront and cylindrical wavefront. First one, spherical wavefront. Wavefront around a point light source are spherical wavefront. For example, wavefronts around a bulb, incandescent bulb. Okay, so such wavefronts are spherical wavefronts. So, for example, this is the light source. These are all wavefronts which are spherical in shape. Okay, so these are spherical wavefront, and any line which is perpendicular to the wavefront is called a ray. So, these are all rays. Okay. Number 2, plane wavefront. Wavefront at large distance from the source is called a plane wavefront. For example, if a light source is at infinity, the wavefronts around the light source are spherical in shape, but when reach the earth, what happens? The wavefronts are plane. Okay, part of the sphere is a plane. Part of a very large sphere is a plane. Okay, so sun, around the sun, example is around the sun wavefronts are spherical in shape, but when reaches the earth, such wavefronts become planar. Okay, so that's about the planar wavefront. When the light source is at infinity, the wavefront reaches the earth becomes planar. So, wavefront at large distance from the source is planar wavefront. So, these are all planar wavefronts. Okay, planar wavefronts, and these are the rays. Rays are always perpendicular to wavefront. Now, the third one is the cylindrical wavefront. When the light source is linear in shape, for example, find rectangular slit, tube light, the wavefront is cylindrical in shape. Okay, fluorescent lamp. For fluorescent lamp or rectangular slit, very thin rectangular slit, the wavefronts are around it are cylindrical in shape. So, such wavefronts are called a cylindrical wavefront, like this. Okay, so this is the light source and wavefronts are cylindrical in shape. So, this is a cylindrical wavefront and this represents the ray. Okay, so thus there are mainly three types of wavefronts: spherical wavefront, that means around a point light source; plane wavefront for a distant light source; cylindrical wavefront for a linear light source. Okay, children. Now we can discuss what is Huygens principle or Huygens geometric construction. Huygens principle is the basis of wave theory of light. It is used to find the shape and location of the wavefront at a later time. For example, if the shape and location of the wavefront at initial time is known, using this Huygens principle we can find out the shape and location of the wavefront at another time or at a later time. Now, according to Huygens principle, each point of the wavefront is the source of secondary disturbance called the wavelets. For example, we can consider this is a light source. Okay, this is the wavefront. This is a spherical wavefront. Here I have drawn only part of the sphere. Okay, so this is actually spherical wavefront, part of the spherical wavefront. Let this wavefront is at the time, initial time t equal to 0. Okay, so consider a light source. This is the initial wavefront AB at time t is equal to 0. In order to find out the shape and location of the wavefront at a later time, okay, at another time, we can consider, according to Huygens principle, each point of the wavefront acts as the source of secondary disturbance. Okay, so that is the principle. First statement is each point of the wavefront is a source of secondary disturbance called the wavelets. So, here this is the wavefront and each point of, there are millions and millions of points here. Here I have drawn only 4 points. The points act as what source of secondary disturbance called a wavelet. So, each point of the wavefront acts as another source and another source or another source of secondary disturbance. Okay. Now with these sources sender, we can construct a sphere. For example, let v be the velocity of light in the medium. Let v be the velocity with which light travels through the particular medium. Consider a time tau. We can consider any time. Let the t be tau. We have to find out the shape and location of the wavefront at another time. Let t is equal to tau. Okay, let v be the velocity of light in the particular medium. We have to find out the shape and location of the wavefront at another time. Let it be tau. So in time tau, what will be the distance covered by the wavefront? It covers a distance v tau, because v be the velocity, tau be the time. So distance is equal to v tau. Okay, so taking this v tau as radius, we can construct some spheres from the sender. So these are the secondary source of disturbance. Keeping this secondary source of disturbance sender, we can draw some spheres. Okay, what is the radius of the sphere? The radius of the sphere be v tau. So like this, with v tau as radius, we can draw number of spheres. These spheres are called wavelets. So these are called wavelets. So with what as the radius? With v tau as the radius, draw number of spheres, keeping this secondary source of disturbance as the sender. So this is a wavefront AB at time t equal to 0. Each point of the wavefront acts as secondary source of disturbance as sources, and keeping v tau as radius, taking v tau as radius, let v be the velocity of light in the medium, tau be the time, okay, and any other time. So keeping this v tau as radius, we can draw number of spheres like this. Clear? Now the next step is, so each point of the wavefront is the source of disturbance, secondary disturbance called wavelet. The wavelet spread out in all directions with the speed of light in the given medium. Let v be the velocity of light in the medium. So these wavelets are spreading with velocity v. The new wavefront at a later time is given by the tangent drawn to these wavelets. So these are the wavelets. Okay, with what as the radius? V tau as the radius, we have drawn number of spheres. And if we draw tangent to these spheres, that gives the new position of the wavefront. New wavefront at any later time is given by the tangent drawn to these wavelets like this. So these are the tangents. Okay, draw tangent to these spheres and join the tangents. We get new position of the wavefront at time t equal to tau. Okay, so we need to find out the wavefront at another time. Okay, and we show a shape and wavefront at another time. Draw number of spheres with v tau as the radius, and draw the tangent and join the tangent, we get the new position of the wavefront. So this is the new wavefront at time t equal to tau. Okay, and here the radius of the wavelet, this is equal to v tau. This is also v tau. Okay, children. Hence, Hygiene's principle is based on these three assumptions. Each point of the wavefront is a source of secondary disturbance called wavelets. Wavelets spread out in all directions with the speed of light in the given medium. New wavefront at any later time is given by the tangent drawn to these wavelets. This is applicable. This Hygiene's principle is applicable for plane wavefront also. Let this is a plane wavefront at time t equal to 0. According to Hygiene's principle, each point of the wavefront acts as secondary source of disturbance. Okay. Now, keeping these points at center, we can draw number of spheres. Similar to the first case, let v be the velocity in the medium and tau be the time. So here also, keeping these points at center, we can draw number of spheres with radius v tau like this. So here, keeping v tau as radius, we have drawn number of spheres. These spheres are called wavelets. Okay, then draw tangent to these wavelets, we will get the new position of the wavefront at time t equal to tau. Okay, so this is the new wavefront. This is the new position and shape of the wavefront at a later time. So it is applicable for spherical wavefront as well as plane wavefront. Therefore, the various steps involved are: consider a spherical or plane wavefront AB at time t equal to 0. If we wish to determine the shape of the wavefront at t is equal to tau, draw spheres of radius v tau from each point on the wavefront. Draw a common tangent to all these spheres, we obtain the new position of the wavefront at t is equal to tau. Thus, we get new wavefront A dash B dash. Hygiene's principle has one shortcoming or one limitation. experimental results do not show the presence of back wave. Here, if you consider the spherical wave, this is the spherical wavefront at time t equal to tau. Here we can draw tangent in the backward region also. Here also we can draw tangent, and here also we can join the tangents, isn't it? Here we can draw the tangent, so EF represents the back wave. Plane wavefront also, here also EF represents the back wave. Okay, so we can draw tangent in the forward region and the backward region also. So experiment result do not show the presence of back wave. The geometric construction and has one shortcoming. We have a back wave EF. Okay, here also we have a back wave EF. The wavelets always propagates in the forward direction. No back wave is possible. So actually from the light source wave is moving in the forward direction. It is diverging out. From the light source waves are moving in the forward direction only, outward direction only. So light is always moving in the outward direction, not converging. So back wave should not be possible. Okay, so there the back wave should be absent in the case of the propagation of the wave. Back wave is not possible. But here actually in a Huygens principle, if you draw the Huygens principle, the geometric construction in the Huygens principle, here we can draw the tangent, here we can draw the back wave. So Hygiene argued that the amplitude of the wavelet is maximum in the forward direction and 0 in the backward direction. Hygiene argued that here amplitude is maximum in the forward direction only, and here this amplitude is 0. Why that amplitude is taken as 0, he could not explain. So that is the main limitation of Huygens principle. Huygens just argued that the amplitude is maximum in the forward direction, that means that light is traveling in the forward direction only, and the amplitude in the backward direction is 0. That slightly explained the absence of back wave. But why that amplitude is 0, he could not explain. So that is a main limitation of Huygens principle. Thus Hygiene argued that amplitude of wavelet is maximum in the forward direction and 0 in the backward direction. Thus Hygiene could not explain the absence of back wave satisfactorily. So he just argued that amplitude is maximum in the forward direction and 0 in the backward direction, but what is the reason behind that, he could not explain. The absence of back wave is really justified by more rigorous wave theory. Highly advanced wave theory could easily explain why the amplitude is 0 in the backward direction. Hygiene could not explain, but highly advanced wave theory could explain. So that is a main limitation of Huygens principle. Okay.